So what do we mean by mathematical rigor? Now, this is kind of one of those terms where everyone just sort of knows what it means, but never really explicitly defines it. Now, I would describe being mathematically rigorous as being very aware of your assumptions. For example, this here is the first postulate from Euclid's Elements. Now, with a little experimentation, drawing some points and connecting them with segments, as you can kind of imagine Euclid himself doing, you can convince yourself pretty quickly that it's true. However, when I read this, looking at it through the lens of my late 20th century mathematics training, the first thought that comes to my mind is, what if the 2 points are the same? Now, by modern standards, the postulate allows that. Part of being mathematically rigorous is being sure that you say what you mean. So if I were writing this, and I meant to exclude that possibility, I would have explicitly added distinct to the statement. All right, now you could reasonably say, well, maybe Euclid knew what he was saying too. Maybe he meant to allow this possibility. But Euclid's mathematics, it was a very concrete thing. Just on its face, it's reasonable to think that at the very least, Euclid would have found the idea of a segment with zero length to be very non-intuitive. But there's more concrete evidence we can point to. Euclid's 32nd proposition says that in any triangle, the sum of the three interior angles of the triangle equals two right angles. In other words, it equals 180 degrees. If we're going to allow zero-length segments, then 3 points occupying the same location would have to form 3 segments, which would have to form a triangle. And even if we somehow contort the definition of a triangle to allow this, it's pretty clear that the sum of the measures of its angles aren't going to be 180 degrees. Being rigorous also means checking your assumptions when you're making arguments. Now, I don't want you to think I'm picking on him, but for an example, we'll look at Euclid again. His 23rd proposition outlines a process for constructing an equilateral triangle based on a segment. So he starts by drawing 2 circles, each with a radius equal to the length of the segment, and centered on the 2 endpoints. Connecting the point where the circles cross with the endpoints of the segment gives you the required triangle. Now, at first glance, that looks pretty good. And it's pretty easy to prove that the triangle is in fact equilateral. The lengths of all 3 sides are equal to the common radius of the circles. It's that point of intersection where things go off track. Now, this is a subtle point that I'll talk about in more detail in another video if anyone's interested. But it's possible, depending on your assumptions, for the 2 circles to not have a point of intersection, in which case there's no way to draw the 2 missing sides of our triangle. Now, as I said, it's a subtle issue, but it's one that a modern mathematician applying a modern standard rigor wouldn't have just let slide. All right, so how does this connect to teaching math? It's the part about making clear arguments that I think has the most relevance to teaching, even at the elementary and secondary levels. Ask your students to explain their thinking. Encourage them to think through their arguments and make sure they're including all the relevant details. When I give tests or quizzes in my ground classes, I always require students to show their work. Now, you can help scaffold this by giving students the question and the answer. Yes, the answer. And telling them to show how to get that result in 3 steps or 4 steps or however many of the process you're trying to get through to demonstrate should take. In more formative assignments, I'll give students the solution with parts removed that they have to fill in. When I'm teaching classes that are introductory proof classes, for example, where students are asked to write proofs for the first time, that's a good way to kind of ease them into being able to do a complete proof on their own. I would also encourage students, even older ones, to explain themselves orally as well as in writing. In the business and professional worlds, you're just as likely to be asked to explain yourself in a staff meeting as you are in an email. So oral communication skills are going to be just as important as those written ones. So if you'd like to see more of this content, you can click on the subscribe link down below. And if you like this particular video, don't forget to click on the like button as well.